other exams that would take into account MPLS. Okay. All right. So let's jump in. All right. So this first question, which statement is correct regarding the default MPLS TTL behavior? Uh, Option number one, when an ingress edge LSR receives an IP packet, it will decrement the IPT time to live field by 1. Then it will set the MPLS time to live field to 255. Okay, that's an option there. Second question, when an ingress edge LSR, same beginning of the question there, or the option there, LSR receives an IP packet, it will decrement the IP TTL field by 1, just as option A there. Then it will copy the decremented IP TTL field into the MPLS label TTL field. Okay. Third one there, same beginning there. When an ingress edge LSR receives an IP packet, it will just copy the IP TTL into the MPLS label TTL. And then D, when an ingress edge LSR receives an IP packet, it will copy the IP TTL field into the MPLS label TTL field first, then it will only decrement the MPLS label field by 1, MPLS label TTL field by 1, okay? And then finally, when an ingress edge LSR receives an IP packet, it will copy the IP TTL field into the MPLS label TTL field first, then it will only decrement the IP TTL field by 1. Okay, so the real core issue here is the order of operations. Um, Obviously, the time to live field impacts how how many hops or how many routers the packet would be allowed to traverse before that packet is would be dropped, basically dropped and no longer being allowed to be routed along to another router. And of course, this mechanism is in place to protect against routing loops, which could go on forever or to infinity, basically, were it not for mechanisms such as the time to live field, and were it not for other mechanisms within routing protocols such as maximum defining a maximum and things like that. Looking at these options here, when an ingress LSR receives an IP packet, it will decrement the IP TTL field by 1. Now that is an absolutely true statement, irrespective of MPLS specific scenarios. Uh, the the time to live field in the IP packet is always decremented by 1 at each hop. And so options A and B, immediately we can see that that portion of the question would be true. When we look at option C there, when it receives an IP packet, we'll just copy the TTL field into the MPLS label TTL field. I'm not going to throw that out right away, but because it did not refute the part that I just indicated, the time to live field decrementing in the IP packet. But we'll leave C for right now. D, let's see, we'll copy the IPTTL first, and then it will decrement the MPLS label TTL field by 1. The reason why this would have to be wrong at the outset is because uh, basic IP behavior is still going to be in place regardless of what MPLS activities are taking place. And so I would throw D out because it does not indicate the decrementing of the decreasing of the TTL field in the IP packet. So D is out. E, when an ingress edge LSR receives an IP packet, will copy the TTL, and then it will only decrement the IP TTL field by 1. Once again, I wouldn't throw that out right away because of the fact that you at least do decrement the IP TTL field. Now, the problem with D, the problem with E, and the problem with C is that once again, this order of operations thing. Uh, when receiving an IP packet, whatever normal IP behaviors would take place, that's going to take place first. And so, that behavior is going to take precedent over any other MPLS behaviors that would take place. And so, E, I would drop that out because of the order of operation then. So D is out, E is out. I would take C out because of the fact that it never really dealt with the decrementing of the TTL field at all. So I would take C out. Then that just leaves us with A and B, and I've actually already sort of shown my hand here and indicated that the fact that with the reception of that IP packet, it's going to deal with the decrementing of the IP um, that the IP TTL field by one. So that actually shows us both A and B as an option there. Then it will copy the decremented. Let's see. Then it will set the MPLS label TTL to 255. The reason why this doesn't make any sense is because that puts it that doesn't decrement the IPL the MPLS TTL field at all. It doesn't. You know there's no dropping of that TTL, and so that doesn't make sense. If this said 254, then that's then we could say that that was the same thing as this second one here. But the problem is, once again, that would be assuming that we started out with 255 from that very first packet. So A, I would throw out because there is no decrementing of the TTL field in the MPLS header here. So the answer here, so we receive the IP packet, decrement the TTL field by one, regardless of what the TTL was already, and then it will copy whatever that is into the MPLS label TTL field to make sure that those two are synchronized. B makes the most sense, and B is the correct answer in this instance. All right, let's move on to the next question here. All right, which three statements are correct regarding ping MPLS command operations? So there are three options here that would be correct, and so let's see A. MPLS OAM has to be enabled on the router using the MPLS OAM command. So option A says MPLS OAM has to be enabled on the router to use the MPLS OAM, or I'm sorry, using the MPLS OAM command. That um, that's absolutely true. Um, in order for MPLS ping to to even be enabled, you have to first and foremost have that command turned on. All right, B, option B says they use a 127/8 address as the destination address in the MPLS echo request packet. What this is actually saying, because it's sort of cryptic the way that they've got it written here. They use actually what it's saying is a 127.000, network address. So basically referring to that, what we know is the reserved loopback addressing space. Um, and so that's what's being referred to here, the fact that it's a 127 reserved address /8, addressed to the destination. And so A is correct here. B is a correct statement. C, they use ICMP echo requests and ICMP echo reply packets. The problem with this is instead of MPLS ping using ICMP, it actually uses the UDP protocol with both source and destination ports of 3503. Um, and so it does a source and destination port 3503. It relies on the MPLS echo request and echo reply that's based upon those UDP port numbers rather than using ICMP. So A and B look good. C, I would throw out. D, they are used to test for broken LSP or label switch path. That is a true statement. Um, and And so let's see, let's take a look at E. If there's a broken LSP, instead of using label switching, the packet can still be forwarded based upon the destination IP address in the MPLS ping echo request packet. That is not true. If the label switch path is broken, the packet cannot be forwarded in this, in, label switching is what we would have to use either way there. Okay. All right. So moving on. Um, so the answers here, of course, A, B, and D. All right. So moving on. What are the four fields inside the MPLS shim header? Um, so let's see. Of course, we have, of course, some things just make sense right off the top, just looking at it. You know that there's going to be a label header. There's going to be a label in the header, right? Um, we just looked at a previous question that, of course, indicated that time to live, that there's a TTL field in there, of course. And so label and TTL, those are good. There is a field called the EXP or experimental field. Um, originally it was used, we referred to as experimental, but later it has been used for for stuff like traffic shaping and QoS, where DSCP values and things like that can be mapped using the EXP value there. So there is an EXP field, there's a time to live field. There is not a version field. Okay, MPLS, there are not different versions of MPLS field that would need to be differentiated within the header itself. Um, there is an S field. This refers to the stack. Okay, how many MPLS labels should be expected? How many labels are stacked there? Um, there is no length field. As I mentioned, there is a label field. There is not a type field, and there is no frame check sequence. So correct answers: A, B, D, and F. All right. Let's do one more question. Which two of the following statements are correct regarding label switch paths? Okay, an LSP is created for every routing protocol entry. That is not true. There's not one for every single routing protocol entry. Let's see. Each LSP is bidirectional. That is, packets traveling in the opposite direction use the same LSP. Not at all correct. Label switch paths are unidirectional. They go in one direction, and the router, the ingress router on one side, um, as 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 the traffic traverses and egresses out the other side, that same router on the other side that was the egress, which is now an ingress coming back in the other direction, might use a completely different path. Ultimately, might use a different path to ultimately get the packet back. So B is incorrect. An IGP is used to populate routing tables in all routers in an MPLS domain. So a couple of things to keep in mind. There's a control plane in your router. There's a control plane. There's a data plane. That control plane involves routing protocols and some type of labeling exchange protocol. The routing protocol populates the routing table, and then the routing table is used. Oh, sorry. The routing table to is used to help build um, what the label exchange protocol will ultimately use for those labels, okay, and the label switching mechanisms. And so the IGP is used to populate the routing tables in all routers, irrespective of the MPLS domain. So the routing table is still always going to be populated by the IGP, completely separate of what's going on with MPLS itself. Okay, the label exchange protocol in most cases, or most common traditional cases, being LDP. Used to be LDP or TDP, but particularly LDP, is more dominant traditional protocol there. That LDP information is going to be contingent upon what is found in the RIB, the routing information base, or the routing table on the router. So C is a correct statement. D, um, LDP is used to propagate labels and build label switch paths. I just indicated that in my discussion or description of C there, and so that is a correct statement as well. The forwarding information base is used to forward MPLS labeled packets down an LSP. That is not a correct statement. Um, the That's going to be used for binding purposes and not to forward MPLS packets down that LSP. So C and D would be the correct answers here. All right, I'm going to stop there, and hope you guys enjoyed the brief discussion here. Thank you for watching. I really appreciate all of your support, and hopefully you guys are enjoying what you're learning through some of these Router Beast videos. Until next time, I'm Raleigh Jones with RouterBeast.com. See you later.